Okay, so for the homework, when you open it up in Cami, you can edit. So for example, in the first one, I want you to draw on the vectors. You can use the drawing tool, or you can draw shapes like I did there to draw in line arrows. All right, so they're my vectors. And then you can use a text box or the drawing to write out, all right, 5 meters, 3 meters. Since it's going to the east, we're going to say right. If it's west, we'll point left. If it's north, we'll go up. And if it's south, we'll go down. And for letter B, they just want the drawing here, right? So it's got to be longer than the two individual guys themselves, especially since they're going in the same direction. Same direction, you add them. Opposite directions, you subtract. And then I'll show another example when we get to the one of the last problems. And then the last one, they wanted to know just, how far was the student from their starting position. So you started here, you went 5 to the east, you went 3 to the east, so you are 8 meters to the east. Okay. That one shouldn't be too bad. Okay, so just again, what happens for something like this? So a student walks 5 meters to the east, then 3 meters to the west. So here's your 5 meters. All right, east is to the right. And then basically turns around and goes 3 meters to the west. That's an ugly 3, but whatever. So I'm just going to plop these next to it just so I know, and it's easier to remember. 5 meters and 3 meters. Now they want you to draw the resultant. Okay. So you went 5 meters to the east or to the right, and then 3 meters back to the west or to the left. So to draw the resultant of that, so from your original position, all right, you went this way, turned around, came back. From your original position, you are, going to be 2 meters. All right, because opposite direction you subtract is, oh God. Nope. Where's the undo button? There we go. All right, so you're going to be 2 meters to the right or to the east. So opposite direction you subtract them, and then the direction that the arrow or your result is going to be in would be the vector of the higher magnitude, which is the 5. So 5 meters. Okay, and so this is going to be 2 meters. Okay, at the end of the walk, how far is the student from their starting position? 2 meters to the east. All right. Now you're going to get one that looks like this. So now when you have a vector that is in the x direction, like your east or west, all right, you have to reduce it till there's only one in that direction, like in that plane. So in the x direction, a net x. And then if you have more than a couple vectors, right, and you have a net y direction, whether it's north or south, you cannot then add or subtract those guys together. So let's just say we wind up with an east and a north. East and a north, you can't add them together. So then what we have to do is we're going to wind up using that equation for the Pythagorean theorem. So, right, let's see, we got 3 east and then 4 north. So 3 east, and then from there we go 4 north. It's an ugly picture. I apologize. Okay, I'm just going to jot those down. So we got 3 meters this way, And we have 4 meters. Nope. Come here. Okay. Dope. Well, they want us to then draw the vector. So, well, we got 3 east, we got 4 north. So we're going to wind up being overall in the northeast direction. So it's going to look something like that. Bam. Now we don't know what that resultant value is. So you would need to do the equation C equals, what do we say? A squared plus, oh, get your ass down here. Come back. All right, so you got to use that equation. But don't forget, you need to take the square root of those two. Oh, God. That's so ugly. But you have this from last week. So you're going to have 3 squared plus 4 squared. Get a number, then square root it. And once you do that, okay, how far is it from its starting position? Remember to have it be completely correct. All right, guys, it's a 3, 4, 5 right triangle. So the answer is going to be 5 meters. But if I just answered the question like that, that's not fully correct because that's not a vector quantity. That's a distance. All right, a vector is something with a direction. All right, you have a magnitude, unit, and a direction. The direction would be northeast. Okay, so for this one, you're going to have something along the lines that looks like this. You're going to go east, you're going to go north, and you're going to go east. All right. So in this case, you want to add the 2 guys in the same direction going together. So the 3.6 east and the 2.4 east. That will give you your total direction in the east direction. That'll give you your total magnitude in the east direction. Then you have your 5.4 meters north. So again, the 2 directions that we have are north and east. So the vector is going to look something like this, along those lines. And then to figure out this guy, you need to use the equation like I showed over here, right? A squared plus B squared, and then square root it. So you have to figure out the total value for the east and then the north to be able to complete that one. And then the last 2, when they say resolve the 2-dimensional vector into its horizontal and vertical components, I'm going to show that. This one you want to use the shapes one for. I'm going to use the red color here. So basically you're breaking this down, right? See how this is north and east? Well, that means we had to have had something that went like this. Hopefully that's close enough. So those would have been basically the 2 vectors. You would have had the one guy going to the east, and then the other dude going upward, all right, going to the north. And then so that black line, that black arrow there is your resultant vector. So you do that, you do the same thing for 7. All right, so this guy's note, again, I didn't answer fully everything, but I gave you, a few problems on your homework. All right, so later on today, I will post this video that I'm recording right now. So there's no reason not to have gotten at least those ones done. All right.